started using additive manufacturing 3 years ago. So that was in 2015 when we started with our first 10 parts.
My company, the Deutsche Bahn, we've been using additive manufacturing for 3 years now. And furthermore, we've initiated a network which is called Mobility Goes Additive, where many companies organize which use additive manufacturing for spare parts too.
I do additive manufacturing, or what we call former rapid prototyping, since 2000. But my company use it since '89. They bought the first, one of the first 3 machines in Europe. It was '89. We are mainly working on spare parts, tools, and infrastructure applications to develop new technologies in our company.
The main application that we are funding are parts that we have to mount into the train, but for produce them you need to build a mold. Using additive manufacturing, we avoid the necessity of the mold, and we can produce the different parts quickly and easily.
We have 3 main areas, so that is spare parts, and then it's tooling and prototyping. But by always increasing the availability, we are focused very much on spare parts.
In our company, the main applications were coming from the energy sector. It's metal parts like burners and nozzles, but also we use for plastics for the mobility sector. The main benefits are most of our rail equipment has been built 30 to 40 years ago with tools like milling, drilling, that couldn't build technologies or functionalities as we can do them with additive manufacturing now.
Because we are looking more at the production side of things, we are looking into making additive manufacturing more efficient to apply in many different industrial sectors. So we are looking at the process itself, the throughput, the quality that you can get out of the process, but at the same time we are working on making a decision support strategy in order to select the right applications for additive manufacturing.
The benefits of these applications are that we can solve our obsolescence problems with additive manufacturing, and we can reduce warehouse costs, because usually those companies which I represent have a lot of spare parts on stock, and those are hundreds of millions of euros. And with additive manufacturing, we will be capable of producing on time, on demand.
Mostly focus on metal additive manufacturing, but this does not exclude other technologies. So we also work in plastics, and we have also worked in the construction sector, so cement printing.
We use some metal technologies like the powder bed laser melting, but nevertheless we use also plastics and FDM technology as well.
In fact, we started using FDM. But later we continue using FDM, but also we bought HP multi-jet fusion. We found the application for this kind of material and for this kind of parts. And now also we have a very big FDM printer, Barcelona, and we are doing with this printer, we are using plastic pellets, technical plastic pellets, and we are able to produce very big parts.
Usually we use a lot of 3D printing technologies, which means fuse deposition modeling, selective laser sintering, selective laser melting, and a lot of more, for instance also wire arc technologies. So all the technologies which can be used for producing spare parts. And since we use a lot of technologies, we usually don't do it on own facilities. We use printing service bureaus, and they are really experts on those machines dealing with the technology.
We are working very intensively on the process itself. So we are trying to understand the process mechanism, and we are trying to improve the quality of the products that we get out of a specific process. That means that we deal with process monitoring, process modeling, not only physics-based modeling, but also models based on data that we gather from the process itself. And we are trying to improve the process both in terms of quality and in terms of throughput and output.
For instance, the design, especially bionic design, and we showed it for new burner designs as well, where you make designs and geometries what you cannot do or produce with conventional technologies. But also, as you mentioned, multi-material will be one of the topics in the next years, definitely.
In CAF digital manufacturing, we use additive manufacturing not only for prototyping, we use it also for final part, as I have said, and we are able to produce the part in only 8-10 hours.
That's a very challenging question. Really what we want additive manufacturing to be in 10 years is a process that is robust enough in order to produce in industrial level. That means that we should have processes that can produce parts that we have no doubts about them, about their properties, and are very well integrated, let's say, in an industrial environment, pretty much like CNCs today compared to what it was in the early 80s.
In 10 years, all our factories will have desktop printers, since the trainees have already started now using desktop printers. We will develop that topic much more in the future. And also there will be a big revolution in the spare parts business. So a much bigger quantity of spare parts will be printed than it is at the moment.
I think and I hope that in 10 years additive manufacturing will be a part of our production line, such as the normal printing or normal technologies, milling, drilling, and so on are today. So that is an addition to our factory. It's not a substitute, but it completes the production possibilities of today.